Hi guys, welcome to my YouTube channel. In this video, we solve the WASSCE 2026 elective mathematics theory questions. Question number 9. If alpha and beta are the non-zero roots of 3x squared minus 11x plus 4 is equal to 0, find the equation whose roots are alpha squared plus 1 on beta and 1 on alpha plus beta squared. Solution. Here we are being told that alpha and beta are the roots of the equation 3x squared minus 11x plus 4 is equal to 0. Then alpha plus beta should be equal to minus b on a, right? Where a is the coefficient of x squared and b is the coefficient of x. So here a is 3 and b is minus 11, right? And so alpha plus beta will be giving us 11 on 3. And also alpha times beta should be equal to c on a. So here c is giving us 4. So we are going to have alpha times beta to be giving us 4 on 3. Let the new roots be r1, which is equal to alpha squared plus 1 on beta, and r2, which is equal to 1 on alpha plus beta squared. Then the equation with roots r1 and r2 is giving us x squared minus the sum, that's r1 plus r2, to x plus r1 times r2 is equal to 0. And so here we need to compute r1 plus r2 and also r1 times r2. Let's compute r1 plus r2. So we are going to have alpha squared plus 1 on beta plus 1 on alpha plus beta squared. So this is going to give us alpha squared plus beta squared plus 1 on alpha plus 1 on beta. But alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta, right? And also 1 on alpha plus 1 on beta is equal to alpha plus beta divided by alpha beta. And so in place of this, we are going to write this, and also in place of this, you're going to write this. Thus, r1 plus r2 is equal to alpha plus beta all squared minus 2 alpha beta plus alpha plus beta divided by alpha beta. Alpha plus beta is giving us 11 on 3, and alpha times beta is giving us 4 on 3. Thus, r1 plus r2 is equal to 11 on 3 all squared minus 2 times 4 on 3 plus 11 on 3 all divided by 4 on 3. Simplifying this, we are going to have r1 plus r2 to be equal to 487 divided by 36. Now, our next step is to compute r1 times r2. So we have alpha squared plus 1 on beta multiplying 1 on alpha times beta squared. So this is going to give us alpha plus alpha squared beta squared plus 1 on alpha beta plus beta. So we can simplify this to get alpha plus beta plus, so here we can rewrite this guy as alpha beta all squared, right? Plus 1 on alpha beta. So we now substitute these values in here. And so r1 times r2 will be giving us alpha plus beta is 11 on 3. Then plus alpha beta is 4 on 3. Then we square it, so that will be 4 on 3 all squared plus 1 divided by 4 on 3. Thus, r1 times r2 is equal to 223 divided by 36. We now have r1 plus r2 and r1 times r2. And so we can find the equation whose roots are alpha squared plus 1 on beta and 1 on alpha plus beta squared. So the equation is giving us x squared minus r1 plus r2, which is 487 divided by 36x plus 223 divided by 36. So we can multiply through by 36, so that's we're going to have 36x squared minus 487x plus 223 is equal to 0.